So welcome everyone, and welcome to our masterclass series. I'm Shachar. I'm the co-founder and CEO of Groundcover. Joining me here today is Erez Levy, which is one of our best and finest founding engineers. Uh, and we're super excited to be here with you and walk over a few interesting topics. Before I let Erez kind of introduce himself better and tell you about the actual content of what we're going to talk about, I just want to perhaps kind of set the stage on what is ground cover, what do we do, why do we all gather here to talk about what we're doing right now. So I'm gonna start off with a few short discussions about what we're gonna see here today. First, as I said, a quick introduction into ground cover, telling you about a bit about our journey and what we're here to solve and how does it relate to the session here. And then we're going to dive right into this specific masterclass and what we have in store for you today. And Erez is going to walk us through a very interesting use case of monitoring Redis clusters, which is always a hard task to do. We'll talk about common challenges, how eBPF can be a very interesting approach and very powerful approach to monitoring Redis clusters, and finish off with a hands-on demo of the product with this specific use case. And of course, your Q&A during the process, which is always relevant. Feel free to stop us at any point. We're always happy to get questions about your challenges, the market we're in, eBPF in general, and the demo itself, of course. So feel free to stop us wherever. We'll also, most of the time in these master classes, we see people that have experimented with the product, and you might have questions. You might come loaded with questions of your own on your experience with groundcover. So feel free to stop me and Erez at any point, and we'll be happy to answer those. Just a quick note about groundcover. Groundcover is an end-to-end observability platform that is built for cloud-native environments. The company has just celebrated its 2 years anniversary a couple of months ago. We have a lot of big customers in production. We're already using eBPF to solve real problems in real use cases and real environments in the cloud. We try to provide a full stack observability platform, from metrics, whether it's infrastructure or application, to traces, log management, and kind of deeper scenarios into Kubernetes troubleshooting, which we excel in the product. And I will kind of walk you through that today as well. And of course, dashboards, alerts, and everything that comes into play with a full observability platform. Our solution, and you're going to see here today, Erez is going to touch on that specifically for the monitoring use case that we're going to cover today, relies on eBPF. eBPF is a very unique technology that allows us to monitor what applications are doing without actually being part of the application code. In regular environments, it would mean that we would save you the trouble to instrument or change the code of your specific application. But in Kubernetes environments or cloud-native environments where microservices architecture kind of rule the domain, instrumented all these bits and pieces becomes super hard, and in most cases it's really hard to get full coverage. So eBPF kind of solves that. It allows us to get a full frictionless onboarding. Groundcover is literally installed in a minute with no code changes and covers 100% of your stack, no matter what language you wrote your code in, no matter if it's a legacy code, if it's a third party. We're going to see everything and every communication, and we're going to use that today for the Redis monitoring use case. And it's very efficient in resources, which in modern life and kind of trying to reduce costs all across the total cost of ownership you have in the cloud is meaningful and very important. Groundcover also relies on a very unique architecture. We completely segregate the data plane and the control plane from one another. So in any way you install groundcover, and there's multiple ways to do so, the data stays on your end. It never leaves your cluster. It never leaves your cloud environment. So all these logs, traces, and metrics you're going to see in this demo are practically stored on your end. So it's private, it's secured, it's reusable. You can hook us up to your systems like Grafana or any alert manager that you would like to work with, and basically kind of reuse the data that we store for you because it's yours. And on the other end, the entire experience is SaaS. You can go into groundcover.com, experience the dashboard that we offer, share it inside your organization, and enjoy all that. without compromising data privacy or paying for tons of money for networking to ship all this data to a SaaS provider on the other end. And the final point is that groundcover, besides eBPF, offers an ability to consolidate all your cloud monitoring in one place. So our eBPF sensor is built for Kubernetes environments. So if you're monitoring Kubernetes environments, you can literally in a minute throw this sensor on any of your clusters and get logs, metrics, and traces with full depth without doing practically nothing. And on the other hand, every data that you already have, whether it's OpenTelemetry traces in your serverless or CloudWatch logs or cloud metrics from the various sources you work with the cloud, you can just aggregate them easily into groundcover and we'll display them together with the data collected from the sensors, so you can work in one place, define alerts in one place, build dashboards in one place, and not have to wander around in multiple systems, which is always a pain. So before I kind of hand it over to the actual demo, Erez, perhaps you can introduce yourself briefly and tell us what we're going to see here today.
Okay, so first of all, hi everyone. My name is Erez Levy. I'm a founding engineer at Groundcover, and I work at Groundcover for almost 2 years now. And it's a great company. We have a great product. And today I'm gonna share with you an example of real root cause analysis that we've had in production in one of the companies that I used to work for. And it really caused us a lot of headache. And it wasn't that easy and that straightforward. And I wish we had groundcover back then, but the company didn't exist back then, so it wasn't even a possibility. And yeah, it's gonna be fun.
Great. So why don't we kick it off? With you taking us through the use case of Redis monitoring and kind of walking through groundcover at the same time.
Cool. So first I'm gonna share my screen. Just a second.
I think Erez dropped off for a second. Just let me bring him back in so we can continue and share the session. Just 1 second. Okay, I see. Erez, I see you joined us.
About that, it's a max permission system. You can give permission without pretty much closing everything.
Yeah, of course, it's always the case, right?
Yeah, exactly. Okay, so let's share the screen for a second. Now that we can have the permission to do so. Okay, so do you see my screen?
Yeah.
Okay, awesome. Okay, so for those of you who may not know what Redis is, Redis is an in-memory, single-threaded key value store with numerous features, different data structures, and it also supports hash maps, queues, lists, and it's an extremely useful tool. And its most common use case in the industry is pretty much a key value cache. It can handle millions of requests per second, maps with millions of keys. My previous work was in the ad tech industry. We had millions of requests per second, and we had Redises all over, and they were able to handle a lot of load. So to get a better sense of the issue, monitoring Redis is not that straightforward. Like any other database, Redis supports monitoring commands like command slow log and monitor operations that gives you the ability to get the currently executed commands. And there are solutions that can be attached to that, like whether it's Grafana dashboard and other third-party services that can use the output of those commands and pretty much try to analyze what's going on in the cluster, in the Redis cluster. I think the major disadvantage is first you're going to have to handle your username and password to that Redis server to a vendor. And the second thing is that you pretty much lose the context. Those commands, like commands that you see on my screen right now, are pretty much returned as text, and they don't have any context or timing on when that Redis call is operated or why it operated, like who's calling it, and all of the context is missing. The second thing you can do, and it's really common, is use OpenTelemetry SDK. You can wrap Redis Redis code blocks with traces of OpenTelemetry, and you can pretty much get a full breakdown, correlate it with distributed tracing, and you can definitely find that issue with OpenTelemetry. The disadvantage of OpenTelemetry in that case is that you definitely need to change code in order to add OpenTelemetry, and you also need the OpenTelemetry infrastructure, like the OTel collector. Like Shahar mentioned, you can use groundcover as a OTel collector in order to use your current OTel instrumentation implementation. We definitely support that. It's very easy to set it up if you would like, but it's definitely not mandatory. And the third thing that you can do, like Shahar mentioned again, is that you can always use groundcover sensors and install them in your cluster as daemon sets. And they pretty much run on all your nodes that are pre-selected by default. You can pretty much decide if you don't wanna install it on specific nodes or areas. And we can definitely aggregate traces for you, aggregate metrics for you, logs, correlate them. And yeah, it's definitely a powerful tool to solve this monitoring problem and so many others, and definitely correlating with different protocols, different services, and pretty much every language, because you don't have to change any code. You don't have to hand over any username and password. You don't need to handle over anything. You just need to set us up. In a minute, you're gonna have pretty much everything installed, and we have great support. If you need any help, we can help you with anything. Okay, so let's move to our root cause analysis. Like any good root cause analysis story, do you see my screen right now?
We see the Redis screen.
Oh yeah, just let me just change the share for a second. Do you see my screen now?
Yeah, it's good.
Okay, so like any good root cause analysis story, it all starts with an alert. And here we can see the groundcover platform. Groundcover had Grafana embedded into it. You can have dashboards and alerts of Grafana. Works as usual in pretty much the regular Grafana. And we have here an alert that is based on groundcover metrics. This is a metric generated by groundcover, and its source is eBPF. And we can see that the metrics is catching latencies that are greater than half a second, which is 500 milliseconds. And that fired metric pretty much told us that this Redis server executed an hget command, a ping command, an hgetAll command, hincrement by. All of those commands are executed at a latency that's higher than 500 milliseconds. So there's clearly something going on with our Redis server. So now that we have the workload name, which is Redis cart, we can go into our workloads tab. So this is the main screen of our application. That's pretty much where you'll land when you go to groundcover and you have a cluster installed. It lists all the workload on your cluster that we identified. You can get a lot of useful information like RPS, error rates, the P95 percentiles, etc. And you can also get all your Kubernetes assets like pods, deployments, daemon sets, stateful sets, even cron jobs, and filter them using namespace filter or just free text that's gonna search on our workloads. So in this example, it's actually the first one because it's sorted on RPS, but we could also search that workload easily and just find that same result. So we're gonna dive into our workload. And once we dived into our workload, we get a lot of information on that specific workload. We're gonna just touch pretty much the core features here, which is the resources, like the CPU and the metrics of that specific workload. We can check out the pods that are related to that workload. Kubernetes events, if they happened during the time span that we're looking at, which is 15 minutes in that case. Logs, if we have logs during that time period. And if it has an APIs that it's serving, we can browse those too. And issues, if they are related to our case. That specific example actually has an issue on an eval operation. It's not, it's clearly not the case here because you can see that the latency is extremely low. It's less than 1 millisecond, but we're gonna dive into traces and you can clearly see how we can dive into things like that issue. So we go back to our Redis cart workload. And we came here to pretty much understand who's calling that Redis server. I think the easiest way is to use our map, as you can see on the right side of the screen. And that Redis cart is pretty much our Redis server. And those are the callers. When you hover on them, you can see the calls and the rates that are happening. And just a useful tool, if you have a way more complex architecture, you can always click the open in a new tab and just move to get a zoomed out in a new window of the map and filter on whatever you want. Okay, so now that we know who's calling it, we're gonna choose the Redis management service to further our investigation. Just a quick notice, we can investigate from the Redis server or from the client. I'm gonna investigate from the client in this example, since most of like the common cases is Redises that are hosted on cloud vendors or like Redis Labs or Amazon or Google. So we're gonna attack from the client. So we're gonna move to traces. This is our traces page. You can filter by various filters. If you have multiple sources like we have here, you can filter on OpenTelemetry, for example, but we're gonna filter on eBPF because we're using data that is picked up by our eBPF sensors. And we can filter on the protocol here, which is Redis, and we can filter on our user management service. Okay, so now we get all the traces of our user management service. By clicking on any trace, we can see the requests and the response, which is like the most commonly used use case for traces. We can get a bit more like general info, whether it's the container name, the pod for easy access. We can get more in-depth information about the container metadata, if there are environment variables passed, If there are passwords, it's a good idea to not putting them to plain. And the image, if you want to investigate, you can get the node name from here, which is useful for investigation of network issues between nodes. You can get the logs around the time of the trace, like the previous and the time after a trace. And you can get what we call context here, which is a bit more general information about who's executing those calls, like the node resources, the container resources, again, Kubernetes events, if we want to get a better sense whether it was recently deployed, and we can also get the RPS and latencies. Okay, so we're gonna circle back to our root cause analysis. And so we know that we have high latency. Actually, we originally we can always sort by latency, but on that specific moment, we can actually see that there is a pretty much breakdown of the latency on the table right now. We can see that there are a lot of HGetAll operations that are taking 1 millisecond, but we can also see that there are HGetAll operations taking more than 600 milliseconds. By clicking on one of them, we can see that, first of all, we're not requesting a lot of keys. Second, the response is relatively small, 200 bytes for Redis, that's like zero. Redis can handle megabytes and hundreds of megabytes on keys. So it is a bit odd for one of the quickest operations on Redis to be executed in such a high latency. And we can even notice that this HGetAll of the user 16, which took 1.2 milliseconds, took that specific request took almost 700 milliseconds. So it is odd. It is definitely odd. When we focus on the timing, we can notice that there's an eval call executed right before the timing started to grow. And for those of you who don't know what an eval call is, Redis can run Lua scripts on the fly. So you can either store a Lua script and pretty much write whatever commands you want to perform. And since it's single-threaded, it will perform all those atomically. And it is very efficient. All depends on what operations you're going to do. And in this example, we pretty much passed all the scripts on evaluation time. And we see that it definitely took a lot of time. And
Erez, we have a small question from Adam about you showing both request and response in the way we kind of investigated the Redis trace. Is that specific to Redis, or is it something more general?
No, definitely not specific to Redis. Just to give you a better example, we could have pretty much switched to pretty much add an insert statement from Postgres and get the request and response relevant to all protocols, relevant even to Kafka and any other thing that we support on the groundcover. Any other questions?
We have another, perhaps a bit less related question, but Ranganta, please help me if I'm misunderstanding that. He's asking about MySQL that has launched 8.1.0 version, and it has an inbuilt OpenTelemetry support. Do we support that, and can we interact with that?
Okay, so it's funny because we saw it on ClickHouse as well. A lot of databases now add the OpenTelemetry support. The thing that you need to keep in mind is that those OTel traces needs to be exported from the database in order to be caught by groundcover or by even OpenTelemetry in general. So um, if you export them, we can even help you set up that to export them to us. We currently don't do it automatically, but we can definitely set up an export procedure with you. And once it's exported from MySQL, we can definitely stream the output to groundcover.
Yeah, we're happy to help over the support channel if needed afterward.
Okay, so we're gonna circle back to our root cause analysis. Okay, so we pretty much touched most of it, but just cutting to the chase. So we pretty much said that since Redis is single-threaded, there's a problem here, and Redis is taking a very long time to perform this eval operation. And this eval operation preventing those really quick HGET calls from getting CPU time. So those calls will only be executed after that eval operation will be finished. And this pretty much what caused the problem. It ended up the root cause analysis, but I'll give you a solution if you experience something like that. It's very easy to use a common Redis and pretty much use large Redises for various applications and use the same Redis for multiple applications. So Redis also supports replications and sharding. So I would advise you to use those features in order to pretty much distribute the load. And if you don't have to share that Redis, like if you're using two different data sets on the same Redis, I would advise you to split them up. Redis is relatively cheap. It has a very small minimum of resources. So you can definitely have multiple Redises. It's usually like computed on resources on all the cloud vendors, not on the amount of Redises you have. I used to work for a company with more than 100 Redises. So it's a lot easier to separate all the risk from that Redis. And it would have definitely solved our problem because that eval was not related to the HGET call operations. And that eval was created by a job that was offlining using that Redis. And that's it. Great.
Thanks, Eris. That was super interesting, and I think like a super relevant use case because it's a cache store. Everybody's using some kind of solution like that, and eventually there's a very big difference between monitoring it with instrumentation or even server-side monitor like we're used to seeing to what you demonstrated here. Any questions before we kind of try to summarize what we just saw? Any questions about in general about groundcover or things that you saw or any other thing? We have a question about how difficult it is to import existing dashboards into Grafana and alerts probably into Grafana, from my Grafana into groundcover. We get it a lot, Eris, right? Because people have stuff that they've been doing already.
Oh yeah, so I'm gonna just to give you a small hinting of how it can easily be solved. You just go to our. I'm gonna simulate just an exporting of a dashboard. You can pretty much just go to the settings and have that JSON model of the dashboard you have. You can just copy it and just throw it on an import dashboard. The import dashboard screen, just paste it, and it won't work on this one just because it has the same name, but I can change the name and change the UID, and it's gonna definitely work. It's extremely easy. You can just edit, import it, and it's working.
Yeah, and I think part of the cool stuff here is eventually using dashboards from the community. I mean, we're completely built towards that. So in Kubernetes and in other stuff, if you have dashboards that you like and you want to import in, even if it's yours, or you have it in the Grafana marketplace or whatever, we know how to help you get on board with that. And for any questions on that, feel free to just shoot them over in our community support, and we'll be happy to help there, because sometimes it's a bit more difficult than it seems to get started with your first dashboard. But other than that, after that, it starts to be you get fluent in that. Great. So any other questions before we wrap it up? Cool. So I think that one of the interesting things about groundcover is the ability to kind of monitor all these things at once. What we just saw here is a very common use case in Redis. We've covered in other masterclasses how you can go through specific bottlenecks in other protocols, or even Kubernetes troubleshooting issues that allow you to dive deep from application to infrastructure issues and kind of drill down on that and cover all of that. We have another comment. I was using this approach of having multiple Redis instead of instances for each app, and we were using Redis on the connector to Redis. Do we have any alerts built in groundcover to know in advance? So Erez, anything to say about alerts that we give in advance?
We currently don't give in advance alerts on those specific one, but it's you can definitely write that on the support, and we will be happy to know any pre-alerts that can be extremely meaningful to clients. We try not to put alerts too much at the beginning, like when people install the system, to not get way too overwhelmed by something that's very specific to specific use case. But we can definitely do that together and help you out.
Great. So thanks everyone. Thanks Erez for the great demonstration. We're always available in our Slack support, and we do these webinars every couple of weeks covering different topics that go through observability use cases, demonstrate how groundcover can practically solve them and help you figure out stuff. Feel free to suggest any topic that you would like to cover in our community or in any other way, and we'll be happy to focus on specific use cases that you might be worried about. I see that Ranganath is still typing. Let's give you a second before we wrap it up. But anyhow, we'll be doing these sessions repetitively, so feel free to join the next ones, and we'll hopefully cover things that will interest you in the next few weeks. So thanks everyone for joining, and thank you Erez, and bye for now. Have a great evening or a great day.
Bye.